calm where nothing happens. However, as recent scientific findings have shown, the red planet is anything but static. The planet continues to be rocked by powerful seismic activities deep within its guts. There is no denying the evidence of volcanic activities on Mars, but the big elephant in the room is Olympus Mons. Where did Olympus Mons come from? Olympus Mons on Mars is the solar system's largest volcano. It is one of a dozen large volcanoes in the Tharsis Montis region near the Martian equator, many of which are 10 to 100 times taller than their terrestrial counterparts. Olympus Mons is the tallest of them all, towering 16 miles or 25 kilometers above the surrounding plains and spanning 374 miles or 601 kilometers, roughly the size of the state of Arizona. In comparison, Hawaii's Mauna Loa, the Earth's tallest volcano, rises 6.3 miles or 10 kilometers above sea level. Olympus Mons has 100 times the volume of Mauna Loa, and the entire Hawaiian island chain from Kauai to Hawaii could fit inside its Martian counterpart. Mount Olympus Mons rises 3 times higher than Mount Everest, which has a peak elevation of 5.5 miles or 8.8 kilometers above sea level. Olympus Mons is a type that scientists call a shield volcano. Shield volcanoes are formed by lava slowly flowing down their sides rather than violently spewing molten material. As a result, the mountain appears low and squat, with an average slope of only 5%. There aren't many impact craters on Olympus Mons' surface when compared to Martian terrain in general. This indicates that the uppermost layer of lava is relatively young, with the most recent eruption occurring only 25 million years ago. This suggests that the volcano is still active and could erupt again in the future. And although it took billions of years to form, some regions of the mountain may only be a few million years old, making them relatively young in the solar system's lifetime. The solar system's tallest volcano may also have rock glaciers and rocky debris frozen in ice. Such glaciers could form as a result of snow and ice deposits above the shield's base. Water ice insulated by surface dust may exist near the volcano's summit. These glaciers' tops may have ridges, furrows, and lobes, as well as be covered in rocks and boulders, and they could be as young as 4 million years old. So why does a massive volcano form on Mars but not on Earth? Scientists think that the lower surface gravity of the red planet combined with higher eruption rates allowed for the lava on Mars to pile up higher. The presence and absence of tectonic plates may also play a role in the various types of volcanoes. The lava hotspots beneath the crust remain in the same location on both planets. However, on Earth, the movement of the crust prevents a steady buildup of lava. The Hawaiian Islands, for example, formed when a plate drifted over a hotspot. Each eruption formed a new small island in a different location. But Mars is a planet with very limited plate movement. Both the hotspot and the crust remain motionless. When lava flows to the surface, it continues to pile up in a single location. Instead of a chain of volcanic islands, large volcanoes such as Olympus Mons form. In fact, 3 other large volcanoes near Olympus Mons are similarly massive. If only one of the 4 volcanoes in the region existed, it would be the tallest feature in the solar system. In addition to the lack of plate movement, Olympus Mons' growth was aided by its long lifespan. A set of 11 Martian meteorites revealed that the volcano had been active for a long time. While the first 10 were only 500 million years old, the 11th, NWA 7635, was discovered to be 2.4 billion years old. But why would scientists assume Mars has been dormant and without any geological rumblings? Well, that will take us billions of years back. Mars was a very different place billions of years ago than it is now, cold and desiccated. It had a thicker, warmer atmosphere, liquid water flowing on its surface, and possibly even life. This is because Mars, like Earth, had a planetary magnetic field generated by action in its core, but when that field vanished, everything changed dramatically. For many years, scientists assumed that this field vanished over 4 billion years ago, causing Mars's atmosphere to be gradually eroded by the solar wind. But according to research led by the University of British Columbia, the magnetic field on Mars existed earlier and lasted hundreds of millions of years longer than previously thought. But that is not the point. Mars's global magnetic field, like Earth's, is thought to be the result of a dynamo effect caused by action in its core. When a liquid outer core revolves around a solid inner core in the opposite direction of the planet's rotation, a magnetic field is generated. Unfortunately, the magnetic field disappeared, which caused the planet's atmosphere to be stripped over time to the point that it became extremely thin as it is today. Scientists attribute this to Mars's lower mass and density, which caused its interior to cool faster. This caused the planet's outer core to solidify, effectively stopping the Martian dynamo effect. Meanwhile, Mars's inner core is thought to be liquid because the pressure in its interior is too low for it to solidify. Previously, scientists relied on the study of magnetized rocks on and beneath Mars's surface to reconstruct the history of the planet's magnetic field, particularly lava rocks. This type of rock forms in the planet's mantle and rises to the surface via volcanic activity and resurfacing. As the lava cools and becomes exposed to the surface, its minerals align with the global magnetic field. So with the loss of its internal dynamo, scientists believed Mars became a gentle giant, not troubled by any seismic activity. However, a recent mission has proven they couldn't have been more wrong. Deep in its belly, the red planet continues to rumble with dynamic tremors. This was thanks to the InSight spacecraft. NASA's InSight spacecraft, which stands for Interior Exploration using Seismic Investigations, Geodesy, and Heat Transport, launched to Mars in May 2018 and landed in November of that year. Its mission was to learn more about the layered interior of Mars so that scientists could compare Mars to what we know about other planets and Earth. One of InSight's primary science instruments, the MOLE, a heat flow probe, failed to function because the soil at the landing site was not as predicted. However, that did not stop it from returning valuable scientific data that tells us what the red planet is like. The design of InSight was inspired by NASA's Phoenix lander, which featured a robotic arm and dual solar arrays that powered the spacecraft's instruments. InSight was about 6 meters or 20 feet wide and a meter or 3 feet tall, including its solar panels. InSight carried out 2 major scientific experiments: a seismometer called SEIS, which measured Marsquakes, and a heat flow probe called HP3, which was designed to burrow up to 5 meters beneath the surface to collect scientific readings. The very first batch of data from NASA's Mars InSight lander provided the first direct evidence of Marsquakes. This places the planet's seismic activity profile somewhere between Earth's high and the Moon's low. And thanks to that haul of information, a series of papers detailing the newly discovered Mars tremors were published by researchers. It was the first mission focused on taking direct geophysical measurements of any planet other than Earth, giving us our first real understanding of Mars's interior structure and geological processes. The set of data boosted our understanding of how the planet works, its seismicity rate, how active it is, and also where it is active. If strong enough, scientists say these tremors can function similarly to a planet-sized ground-penetrating radar, but with seismic waves rather than electromagnetic waves. As these waves travel through a planet, they can slow down or bounce off certain materials, allowing seismologists to work out the interior composition. The type of tremor can also reveal information. For example, the Earth's moving tectonic plates cause much of the planet's seismic activity. The Moon, on the other hand, lacks tectonic plates entirely. Seismic activity is caused by the slow and slight shrinking that occurs as our satellite cools, a process that has been ongoing since its formation 4.5 billion years ago. Back on Mars, though, the first tremor wasn't powerful enough to detect much. However, the instrument recorded 174 Marsquakes in 235 Martian days. 100 of these were high-frequency tremors similar to those recorded by Apollo experiment on the Moon. The remaining 24 quakes, on the other hand, were of low frequency. This is particularly intriguing because it went against the assumption that the planet is relatively tectonically quiet. The other 24 had a predominance of low-frequency content, and their spectral shapes follow the same scaling laws as earthquakes and moonquakes, leading to the conclusion that they are of tectonic origin. The properties of these spectra are consistent with predictions for distant tectonic events. Furthermore, the way the waves propagate through the crust can be used to pinpoint the source of the quakes. 3 of the 24 Earth-like quakes were strong enough to attempt this. 2 of those 3 quakes was traced to the Cerberus fossae region, which contains a series of fissures caused by faults that pulled the crust apart. Evidence suggests that it was recently tectonically and volcanically active, that is, within the last 10 million years. That might sound like forever, but hey, in rocks, it's not long. Another paper based on SEIS data sought something different: the interior composition of Mars. They discovered that a layer of regolith down to a few meters and beyond that the Mars crust to a depth of 8 to 11 kilometers or 5 to 7 miles is highly altered or damaged. Furthermore, the way the waves are stretched out in the crust suggests that it contains small amounts of volatiles, more than the Moon but less than Earth. But wait, there's more. InSight is not only outfitted with seismic instruments, but it's also measuring the atmosphere and the geology of its landing site. A team of researchers studied the planet's magnetic field at the InSight landing site in another paper. Now, Mars has a relatively weak magnetic field which is thought to contribute to its inhospitable nature, but their findings indicate that Mars was not always this way. They discovered that the field was 10 times stronger than predicted by satellite-based models, and they inferred magnetized rocks beneath the surface within about 150 kilometers of the landing site, consistent with a past dynamo of Earth-like strength. But InSight would go on to detect even more Marsquakes. In its nearly 1,300 days on Mars, InSight has detected more than 1,313 Marsquakes. The mother of them all had a magnitude of 4.7, making it 5 times stronger than the previous largest quake on Mars, which occurred in 2021 and had a magnitude of around 4.2. Another indication of the magnitude of the event is that InSight continued to detect waves from the record-breaking quake for approximately 10 hours, whereas all previous Mars quakes had subsided within an hour. The energy released by this single Mars quake was equivalent to the total energy released by all other Mars quakes we've seen so far. Despite the fact that the event was over 2,000 kilometers or 1,200 miles away, the waves recorded at InSight were so large that they nearly saturated the seismometer. This particular quake was also unusual in that its epicenter was not near any known nodes of activity. It also exhibited characteristics of both types of Marsquakes that have been identified thus far: high-frequency waves with rapid but shorter vibrations and low-frequency waves with greater amplitude. The Marsquake happened on Sol 1222 of the InSight mission. On Mars, a Sol is 1 day and lasts about 40 minutes longer than a day on Earth. Now, in reality, a magnitude 5 quake would be insignificant on Earth. Such earthquakes occur 500,000 times per year on our planet and rarely cause serious damage. They may throw things off shelves, crack windows, and wake you up at night, but they won't hurt anyone. Mars, on the other hand, is much more peaceful tectonically, and a magnitude 5 quake was about as powerful as scientists hoped for when they sent InSight to the Red Planet. Another set of researchers examined the data from the Mars quakes and came to another conclusion proving Mars is far from a resting giant. They discovered magma was likely on Mars. They looked at a group of over 20 recent Marsquakes that originated in the Cerberus Fossae-Gaben system. Scientists concluded from the seismic data that the low-frequency quakes indicate a potentially warm source that could be explained by current molten lava, that is, magma at that depth and volcanic activity on Mars. They discovered that the quakes are mostly concentrated in the innermost part of Cerberus Fossae. They discovered darker deposits of dust not only in the dominant direction of the wind, but also in multiple directions surrounding the Cerberus Fossae mantling unit when they compared seismic data with observational images of the same area. The darker color of the dust indicates geological evidence of recent volcanic activity, possibly within the last 50,000 years. The tremors emanating from the nearby Cerberus Fossae, named after a creature from Greek mythology known as the Hellhound of Hades, who guards the underworld, is a direct pointer that Mars is not yet dead. The weight of the volcanic region sinks, forming parallel graben or rifts that pull the crust of Mars apart, similar to the cracks that appear on the top of a baking cake. It is possible that these are the last remnants of this once active volcanic region, or that the magma is right now moving eastward to the next location of the eruption. One thing, however, that InSight also detected was that Martian tremors can come from elsewhere besides the deep crust. It actually recorded at least one that came from above. The InSight lander detected a magnitude 4 Marsquake on December 24, 2021, but scientists only discovered the cause later. A meteoroid strike estimated to be one of the largest seen on Mars since NASA began exploring the cosmos. Furthermore, the meteoroid unearthed boulder-sized chunks of ice buried closer to the Martian equator than had previously been discovered, a discovery that has implications for NASA's future plans to send astronauts to the Red Planet. Scientists determined the quake was caused by a meteoroid impact after noticing a new yawning crater in before and after images from NASA's Mars Reconnaissance Orbiter (MRO). The event and its effects provided a rare opportunity to see how a large impact shook the ground on Mars. The meteoroid's diameter is estimated to be 16 to 39 feet or 5 to 12 meters. That would have been small enough to burn up in Earth's atmosphere, but not in Mars's thin atmosphere, which is only 1% as dense as our planet's. The impact created a crater 492 feet or 150 meters across and 70 feet or 21 meters deep in the Amazonas Planitia region. Some of the ejecta thrown by the impact traveled up to 23 miles or 37 kilometers. With images and seismic data to back it up, this is thought to be one of the largest craters ever seen forming anywhere in the solar system. There are many larger craters on Mars, but they are much older and predate any Mars mission. Finding a new impact of this magnitude was unprecedented. It was like getting a front-row seat to watch an exciting moment in geologic history. But the quake resulting from the meteor impact was the first observed to have surface waves, a kind of seismic wave that ripples along the top of a planet's crust. The waves aided scientists in understanding the structure of Mars's crust. The crater was first spotted on February 2022 by scientists working at Malin Space Science Systems, which built and operated 2 cameras aboard MRO. The Context camera CTX produces black and white medium-resolution images, whereas the Mars Color Imager MARSI generates daily maps of the entire planet, allowing scientists to track large-scale weather changes such as the recent regional dust storm, which reduced InSight's solar power even further. The blast zone of the impact was visible in MARSI data, allowing the team to pinpoint a 24-hour period during which the impact occurred. These observations correlated with the seismic epicenter, concluding that the large Marsquake was caused by a meteoroid impact. It is critical to determine the rate at which craters appear on Mars in order to refine the planet's geologic timeline. There are more craters on older surfaces such as Mars and our Moon than on Earth. On our planet, erosion and plate tectonics erase older features from the surface. New craters on Mars also reveal materials beneath the surface. Large chunks of ice scattered by the impact were observed by MRO's high-resolution imaging science experiment color camera in this case. Subsurface ice will be a valuable resource for astronauts who will be able to use it for a variety of purposes, such as drinking water, agriculture, and rocket propellant. Buried ice has never been discovered this close to the Martian equator, which is an appealing location for astronauts because it's the warmest part of Mars. Let's hear what you think of Mars exploration in the